I'm going to switch websites because that's driving me nuts.
Yeah. I just started playing World of Warcraft, the most expensive game I know of. And because it's like $20 to buy the game, $50 for the new expansion pack, and then you just pay on top of that a $13 fee every 3 months.
Just to be online?
Just to play the game.
You know how long that game has been around?
Yeah, since 2004.
It's crazy.
Yeah.
Are you at least enjoying it?
Yeah, I am enjoying it. I haven't paid for it yet. I have a free month, and then if I buy the game, I get another free month. So I'm living out these 3 months.
Oh God, I haven't had any time to do anything. But I actually did have a friend in school that like loves playing that game still. I'm like, you're 40, shouldn't you? I guess it.
Yeah, my friend's dad was a beta tester for the game, so he's known about it his whole life, and he finally got me to play it, and he was so excited, and I was like, this game is so expensive, stop.
Are you addicted yet?
No.
No? Okay.
No, I'm still addicted to League of Legends, which is actually a spin-off of a mod of that game.
Oh.
So, I wouldn't be able to play League of Legends if it weren't for this game.
Right. Well, because of that, were you okay with like the movements and stuff inside of the game and everything?
It was a lot easier to adapt.
Yeah. Okay, what did it ask us?
Volume in tank 1 and tank 2, which I'm assuming is V1 and V2.
Right.
Yeah. 1, 2, 3. See what the other ones do.
Oh, Lord Jesus. Sorry. I have a box that is 1.2 meters long, 54 centimeters deep, and a couple of millimeters high. The length of the diagonals across the volume of the box. Okay. So we're going to have to do Pythagorean theorem. I'm going to try to draw this the way they have it set up. So it's three-dimensional, and I need to use a different pen than that. So let's see if I can do this. Okay, so tell me the measurements again. I'm sorry.
1.2 meters long, 54 centimeters deep.
Let's convert that to meters.
Okay, so 0.54 centimeters deep. Well, meters.
Meters, okay.
And then 780 millimeters high.
Which is 0.78.
0.078 millimeters.
How many millimeters in a meter?
1,000.
1,000. So move it 3 places.
Oh.
See how I got it?
Yeah.
Okay, so now I'm going to draw the triangles that I want you to figure out because they want to know that line.
Okay.
Okay? So what I'm going to do is I'm going to draw one triangle in green. See that diagonal we have to figure out?
Yeah.
And then I'm going to draw the final triangle in blue. And this is the length that we're looking for. Can you picture that?
Yeah.
So here is one of my right angles. Right? Mm-hmm. That's along the bottom. And then my other right angle is there.
So So you have to find one to find the other.
You have to find one to find another, because this is going to be the base of our triangle, so we can figure out, because I know that that side is how much. What's that length of that blue line right there?
0.78 meters.
We don't know this, right? But we have that bottom triangle, so that is the what of this triangle. What's that line?
That line is the adjacent line?
Hypotenuse?
Oh, the hypotenuse.
Do you see it?
Yeah.
Okay, so how do you find the hypotenuse of a right triangle? And I need to tape this, sorry. I stopped. No, I didn't. I did it. Okay. Okay, so how do you find the hypotenuse of that?
12 squared, or 1.2, plus 0.54 squared.
Right?
Yeah.
I'll call that Y, just to label our different parts. Alright, so let our calculator do all our work for us. So we've got 1.2 squared plus 0.45 squared. And so that's 1.3. Okay, and now what's my other Pythagorean theorem that I need to do to find x?
Square root. Square root.
Oh, I did. That is my square root symbol, sorry. Oh, I did that. That is the square root of that is 1.3. I did it all on my calculator all at once, sorry. See? It's already there.
Yeah. Now we take 1.3 and 0.78 and do that.
Alright, so I'm going to take second answer squared plus 0.78 squared, and so that's 1.5. Ooh, that's really sloppy. 1.5. And that's meters. Do you remember the law of sines and the law of cosines?
Yeah, but I also know that this one's 38.
Right. That is true.
Yeah, I don't know. I know what they are and I don't know the formulas, but I know how to use them.
Okay. Let me redraw your picture you got there. I'll try anyway. Trash. Oh my God, no. No. Trash. There we go. Alright, so we have a straight line and then some random triangle. We know that this is 38 and that angle is beta, and then we got gamma and alpha. This is 1.7, this is 1.33, this is 2.54. Okay, so I know that beta is equal to 38. You already told me that. And I'm going to say that the beta side, I'm going to call this side B. I'm going to call this side C. And I'm going to call that side A. Because they're opposite the angles. And that's the way they normally do that for the law of sines.
Yeah.
Okay. So I can say that the sine of alpha over A is equal to the sine of beta over B is equal to the sine of gamma over C. So now I'm just going to do these two at a time and then solve for the other two angles.
Okay. So, yeah. Sine.
So the sine of alpha over 1.33 is equal to the sine of 38 over 1.7. Did I set that up right?
Yes.
And so I can say that alpha is equal to, whenever you're solving for the angle, you always use the inverse trig function. Do you remember that from last year?
Yeah.
Okay. So I'll do it in 2 steps so it doesn't seem so confusing. So I'm just going to move that up there. So it's 1.33 sine of 38 divided by 1.7. Sorry, I'm dragging this thing all over the place. So we're going to do that in the calculator. 1.33. Oops. What is going on? Let me make sure the mode is right. Yeah. Of 38 divided by 1.7. Oops. So that means that the sine of alpha was equal to 4.82. 0.482. And so alpha is equal to the sine inverse of 4.482. So I just do that in the calculator. So second sine, second answer. And so that's 29 degrees. Okay, you set up the next one.
Okay. Well,
You can do that. That's fine.
yeah, I know what I'm talking about.
Now solve for it for me.
So this goes up here, right?
that goes up there. Is that what you're saying?
Yeah.
Okay.
I just said it in reverse.
Let me get my mouse out. It's just easier to use a calculator than that.
Mouses are great. I learned that when I started gaming.
Yeah.
I had no idea how important a mouse could be. Because I tried to play TF2 without a mouse.
Oh no. My mouse is dead. Oh, maybe not. Maybe it is. Man, I didn't even put the cheap ones in here. I got Duracells in here. This thing should still be working. Let's decide.
Blame an engineer.
Huh?
Blame an engineer.
It's not supposed to do that. Oh my god. Never mind. We saw. I don't get it. Okay, I'm done. I'm really done. Okay. All right. What am I dividing? What am I doing?
2.54.
Sorry. 2.54
times sine of 38. Then divided by 1.7.
and then sine inverse of the answer.
Yeah.
I guess that's what happens when you spend $5 at Big Lots to buy a mouse. You do get what you pay for.
Yeah, all my mouses have come from Five Below.
Oh, really? They sell them there too?
Yeah.
Can I borrow one of your papers over there?
Yeah.
It's so reflective. It's not really working that well. Thank you. There we go. Maybe not. No. No good. Oh. Okay. So we have 2 of the angles. How do you find the third?
We have 3 of the angles.
Oh, we didn't even have to do that again.
Yeah.
We could have just subtracted from 180. I didn't even think about it.
Yeah, I thought about that after I did it too.
Does it all add up to 180?
Let's see.
Or close to?
Yeah, I think so at least.
Okay, so plus 38 plus 29. No, it doesn't. Okay, so that means that we found that angle on that side. So what was gamma? 67? So
Yeah.
take 67 minus 180. Because that's actually going to give us the obtuse angle. Because that's a, what kind of an angle?
That's an obtuse angle?
Do you know the difference between obtuse and acute?
Yeah. One goes like this and one's like this.
So is 67 an obtuse angle or an acute angle?
That's an acute angle.
That's an acute angle. So I have to take 67 minus 180 in order to get the right answer. So 180 minus 67, that gives me 113. So that angle is actually 113. When you use the law of sines, you could have what's called the, I was going to say oblivious, it's not oblivious, it's the ambiguous case, where you have two different angles. One angle's acute and one angle's obtuse. So we found, because, okay, I'll show you how that comes to be. And of course, let's do this. Because if I take 113 plus 29 plus 38, I get 180. Okay, so this is what happened. And of course your engineering teacher is going to do that, because he's going to try to make sure if you're paying attention or not. So one triangle looks like that. The other triangle looks like that. And this is an isosceles triangle. So that length right there is 1.7, and this length where that green line out there is 1.7. So the angle that we found was 67. So the 67 triangle would look like that. Okay. So because this is an isosceles triangle, that means that this angle is 67. And that's why I took 180 minus 67 to find out what our gamma was. That's where that came from.
Okay.
So be careful when you're using law of sines, because you might get the ambiguous case where there's two different answers for the triangle. Obviously, this angle alpha up here would be a lot larger than 29, right?
Yeah.
It's 67 plus 67 minus 180. That gives us this piece, and then you add those two together, and that would give you this obtuse angle up here. So that's why I said be careful. So when that number didn't come out to be bigger than 90 degrees, we should have known something was wrong. And we caught it. Did you see where I got that from? Oh, gotta plug this in.
Yeah.
So all that being said, make sure you check when you use the law of sines to make sure that everything adds up to 180. And if it doesn't, then remember you should just subtract the base angle from 180 to find out what it is.
Okay.
Okay. All right. What's the next question?
Given the relationships 12x plus 63y equals 651.9 meters and 21y minus 15x minus 47.8 meters equals 104.9 meters, solve for x and y. Use the elimination method.
Do you know how to use the elimination method?
No.
Okay. So I'm going to make you do the math for this, but I'll walk you through it. So it's 12x plus 63y equals 651.9. And then this is 21x minus 15y equals, is that negative 47.8?
Yes.
Okay, so I need to eliminate one variable at a time. So I'm always going to focus on the ones that have opposite sign. So it's that one and that one.
Okay.
And I need to make them the exact same number.
So your X and your Y are backwards from the paper.
Do I?
On the bottom one.
Did I write them backwards? I'm sorry.
Yeah.
Oh, well then, yeah, I need to flip that because that's not going to help us. Good catch. So this is minus 15x?
No, 21x. No, 21y.
And it's minus 15x, right?
Yeah.
Oh, there's three different numbers there. That's what I did wrong. So it's minus 15x plus 21y, and then it says minus 40. So I'm going to make this plus, so I'm going to move that number over there. And then this was plus 104.9. Do you see what I did there?
Yeah.
Because I want to make sure that the x's are stacked on top of one another and the y's are stacked on top of one another. It's just easier to do that way.
Okay. Okay.
So let me use my calculator to add those two numbers up. So this is 47.8 plus 104.9. So this is 152.7. Okay, so I'm going to rewrite it again. So this is minus 15x plus 21y equals that number. And this is 12x plus 63y equals this number. Okay, so how do I make these two numbers the same? What is the least common multiple of 15 and 12? Here's another way to look at it. What number do 15 and 12 have in common?
3.
They both have a 3 in it. So I'm going to ignore that number. What number do I have to multiply 15 by to make it, what number do I have to multiply 3 by in order to make it 15?
4. No, that's so wrong. 5.
What about this one?
4.
So those are the numbers that they don't have in common, right?
Yes.
So if I take this bottom equation and multiply it by 5, and I take this top equation and multiply it by 4, look what happens. 4 times 15 is 60. right?
Mm-hmm.
5 times 12 is also 60. So if you take the number that they don't have in common and you flip-flop them, you multiply them, you'll end up getting the same number.
Okay.
Okay? So I'm going to distribute that all the way through. So this is negative 60x plus 84y is equal to, I'm just going to multiply that, 152 times 4. So this is 610.8. And then I have 60x plus 63 times 5. 315y equals, and that's 651.9 times 5. Oops. 3,259.5. Was it 59.5?
Yeah.
Now I'm just going to add those two equations to one another. What happens to your x's?
They disappear.
They cancel. That's why it's called elimination, because you just got rid of the x's.
Oh.
And
Okay.
then we're just going to add, because now I'm just going to have everything in terms of y. I like doing elimination way better than substitution because it's easier.
Yeah, I see that.
So we have 84 plus 315. That gives me 399y. And then I have 3259.5 plus 610.8. 3,870.3. And then we just divide. So y is equal to 9.7.
Okay.
And now we can just substitute in. Do you have a druther which one you would rather plug into? It actually doesn't matter. So I'm going to take this value and I'm just going to plug it into the top equation. So 12x is equal to 651.9 minus 63 times 9.7. So let's figure out what that is. So 12x is equal to 40.8. So x is equal to 3.4.
Okay.
Do you remember your definitions?
No.
What does the word supplementary mean? Do you remember that?
No.
It means 180. So what angle can I add to A and get a straight line?
C.
Or?
B.
So either one would work.
Would that be B and C? Consecutive exterior angles.
C is inside the two parallel lines, right? So exterior has to be outside.
Oh, so.
On the same side of the line, too. There's only one answer for that one.
A.
Those are supplementary. These two are exterior consecutive. Because if you travel along that line, those two are on the inside, right? So that's the next one that's on the outside.
Yeah. So then that would be D and F.
Mm-hmm.
Interior. G?
G, good. Yeah, you do remember some of this stuff.
Yeah, I guess so. So D and E?
Mm-hmm.
Would that be B and C corresponding?
Corresponding is every other one on the same side.
So yeah, B and C.
On the same side of the line. So on this side of the line.
So B and D.
Those are supplementary, so every other one. So if it's that one, it's not that one. It's the very next one on the line. So it would be that one. Those are corresponding to one another.
Oh. Okay. And vertical is X. What's a vertical angle?
Across the vertex.
Oh. Okay.
How you knew that one was 38? Because they were vertical to one another. Oh my god. Vectors.
Yep.
Okay, a triangle is formed from F1, F2, and R. The dotted line is anti-clockwise 15 degrees and is parallel to F2. So I love engineers. They try to make stuff so difficult when it's not. Okay, so if I were to draw a little axis there, right?
Yeah.
Let me have your pencil.
Okay.
So I'm going to draw a little axis right there. And let's extend the axis out. How many degrees from there to there?
15.
15. That's the way you break down a vector into its components anyway. So if I'm going to extend this line out, this is going to form a right triangle. I did a horrible job of drawing that, right?
Yeah.
So my right triangle, and I'll draw the picture here. All vectors can be drawn as right triangles. So I'm going to take this line and this line, and I'm going to split it into its components, which means I'm going to split it into its x and y parts. The thing that you have to remember is that if I have, I'm going to draw, let's draw F1 first. So I know I did a horrible job drawing F1, but I don't care. It doesn't really matter anyway. So this is F1. The angle from there to there is 30, right?
Mm-hmm.
I can always make a right triangle out of F1 by using the x-axis and drawing a line up to it. So if I'm going to break it down into its components, this is the right triangle that I care about. Okay?
Mm-hmm.
This is the x part of that. this is the y part of that. The x part is always related to the cosine trig function of the angle, and this is my angle that I care about. How many degrees in that?
60.
Okay. So the x part is going to be f1 cosine of 60. X is always cosine. The y part of this vector is always related to the sine of the vector of the exact same angle. So this would be f1 sine of 60. You can do all vectors that way by just looking at the individual lines.
Okay.
Okay? So if I'm drawing f2, that's f2. I'm going to make my right triangle again. How many degrees here?
15.
Can you tell me what this side is going to be equal to then? If I'm following the same pattern.
Cosine of 15.
What did I multiply it by in the front of it?
F2.
F2. So that's F2. I'm sure they gave us what the lengths of them are. They did. We can substitute it in later. I just want to show you that it doesn't matter what that number is. You're going to do the exact same thing over and over again. Tell me what this y part is equal to.
F2 sine of 15.
Okay? So now, because I have my components, I can make what's called a vector table. And your teacher might not teach it to you this way, but I think it's a good way of organizing the stuff. These are all the x's. These are all the y's.
Okay.
Does any of this stuff look familiar? Did you do vectors before? Have you done them before? Did you do
Yeah,
it?
we did in physics.
Okay. So I'm just going to label my x's. So I have, and I can actually stick in the number now. What's f1 equal to?
F1 is equal to 8.
So this is 8 cosine 60, and this would be 8 sine 60. And what's my other one?
It's not the same.
Oh, one's in inches and the other's in feet?
Yeah.
Take the feet, because we already wrote the 8. Take the feet and multiply it by 12. Right?
Yeah. So that's what, 14.4?
Mm-hmm.
Yeah.
14. Yeah, that makes sense. 14.4. Okay, so this is 14.4 cosine of 15, and this is 14.4 sine of 15. Now I'm just going to add the x's together. So I actually got to use a calculator to do that. So this is 8 cosine 60 plus 14.4 cosine of 15.
Wait, wouldn't it be sine of 15? Oh no, you're doing the same one.
I'm doing the same ones. The x's are the x's and the y's are the y's. Never the twain shall meet until we use the square root, the Pythagorean theorem, to figure it out.
Okay.
So the x part is going to be 17.9, or is it 18? It's 17.9. And then I'm going to do the same part with this. So this is 8 sine of 60 plus, plus 14.4 sine of 15. And that part is equal to 10.7. Okay? Now I'm going to redraw my triangle. That's going to give me this line. So when I redraw my triangle, I've got 17.9 that way and 10.7 up. And this is my R. What do I use to find R?
Pythagorean theorem.
Mm-hmm. Oh, gosh. Okay. So, let's just do that. I hate when it does that. Alright, so we've got the answer squared plus 17.9 squared. And then I take the square root of that. So R is equal to, it's at 20.8. And now you're going to have to use, well, actually, you don't necessarily have to. If that's 15, yeah, you're gonna have to use law of sines now, because now you have all three sides. And you're gonna use law of cosines to find the angles for each.
Are we finding the angles?
It says I have. Oh, actually, as references only, no. So you just need to know the magnitude of R. So we got that in inches. Oh, good. We did it in inches. They actually asked for the answer in inches, so we did it the right way.
Okay, good. So that would be helpful.
Okay. Let me stop the video.